So in this problem, we would like to use the divergence theorem in order to compute the outward flux. So compute the outward flux of f of x, y, z equal to x cubed minus sine of y squared 5z minus e to the y squared through the boundary of 0, 1 cross 0, 1 cross 0, 1. This is a cube, a unit cube. So what do we need to know here? Here we need to know that the the double integral that gives the outward flux. So you can denote this way. Your book doesn't seem to write to like so much this notation. So the notation that your book has is actually the double integral of f dot n ds. But in any case, no matter how you look at it, this integral will be just the triple integral of the divergence of f in the interior of that domain. And I remind you that the divergence of f is simply the gradient operator dot f, which means that if f is the vector field that has components p, q, and r, then the divergence of f is the derivative of p with respect to x plus the derivative of q with respect to y plus the derivative of r with respect to z. So that's what we need to remember in terms of our theory. So applying this in our case is very simple because the divergence of the vector field f is the derivative with respect to x of x cubed minus sine of y y squared. When I write this symbol, I really mean partial derivative with respect to x of the quantity x cubed minus sine of y squared. It's not multiplication, it's application of a differentiation operator, if you will. So partial derivative with respect to y of y squared plus partial derivative with respect to z of 5z minus e to the y squared. So this is equal to 3x squared plus 2y plus 5. And that's what we need to integrate. So when we integrate this, and here we can go directly to our triple integral. This is a very simple integration that can be done in stages. So we will have first the antiderivative with respect to x. So that will be x cubed plus 2yx plus 5x from 0 to 1. So sorry about this. The Zoom is playing some games on me here. Okay. So this will be integral 0, 1, 0, 1, 1 plus 2y plus 5 dy dc. So it's 2y plus 6 to make our life easier. So this will give you, the antiderivative will be y squared plus 6y from 0 to 1, and then the integral dz, which will give you the integral from 0 to 1 of 7 dz, which will be oops, didn't intend to do this arrow. But I don't seem to be able to get rid of it now. Well, this is z, and this is 7. Okay, sorry for the technical difficulties. That's it.